Hey Ramblers, today we're going to talk about the algebraic applications to geometry. So I told you that this class is going to be a lot of memorizing, and that memorizing is going to help you set up equations that you can solve algebraically. So we're going to start off with three examples today in this video, and hopefully it'll give you a sense of where the class is going. So the first thing we're going to do is take out that file that I gave you attached to, I think it was day one in the topics section. It was called Geometry Building Blocks. So if you don't have that yet, why don't you pause the video, go into the topics under day one, and find the Geometry Building Blocks file, because we're going to use three of the examples from those pages. All right, so we take a look at the first one at the top of the page, and we see that we have an angle that's been divided into two parts. So it tells us that the measure of angle ABC is equal to the measure of angle DBC. So that little M in front of each of the angle symbols indicates measure. So why don't we start off with that? Let's start off with an equation using that information. So we know that the measure of angle ABC is equal to the measure of angle DBC. Okay, using that information, I see that the measure of angle ABC is 2x plus 4y minus 1, and the measure of angle DBC is 5x plus 3y. So let's get all the variables over to one side equal to a constant. So that's going to mean negative 3x plus y equals 1. And at this point, when you get it in that form, I'd like you to put a box around it. Now, we have two variables, so we need another equation. Let's go back to the diagram and the given information and figure out what can we determine, what other equation can we set up. We don't want to do something like just rewrite the one we have or multiply it by 2. We need a distinct equation. And I'm going to pay attention to the little square symbol, that tick mark down in the corner. That means that angle ABD is equal to 90 degrees. So that's going to give us a second equation. Angle ABD, I should say the measure of angle ABD, is equal to 90 degrees. So since I see that the angle ABD is made up of those other two angles, I can start to rewrite the measure of angle ABD as 2x plus 4y minus 1 plus 5x plus 3y and set that equal to 90. Now let's collect like terms. We have 7x plus 7y equals 91. Now I'm going to put a box around that as well. And so now I have two equations. And usually in this class, the elimination method is going to work. But since we have a coefficient of 1 up in the for the y term in the prior equation, let's just use substitution. It's probably going to be quicker. So since y equals 3x plus 1, I'm going to rewrite this as 7x plus 7 times the quantity 3x plus 1 equals 91. Now let's simplify that and solve for x. So we have 7x plus 21x plus 7 equals 91. Then 28x equals 84. Dividing both sides by 28 tells me that x is going to equal 3. All right, so now I'm just going to use back substitution by plugging, since I solved for y, I just have to plug my 3 in for x, and I see that y equals 3 times 3 plus 1, so y equals 10. Okay, it's really important in this class that you're able to solve systems of equations. In other words, two variables with two equations. We'll use the elimination method often, but we'll also use the substitution method. So just make sure you're comfortable with that. Okay, let's go to the next page and try this other diagram, and we'll work with number 2. Okay, number 2, we need to solve for just one variable, x. So we'll only need one equation. Can you pause the video, take a look at the diagram, and see what equation would you come up with in order to solve this? Okay, well hopefully you noticed that the measure of angle ATR is made up of three smaller angles. So I can say that angle ATR equals angle ATV plus angle VTR plus angle RTN. So if I substitute in the expressions for those angles, I can see that angle ATV is 10x plus 12, angle VTR is 7x plus 4, and RTN is 3x plus 4. And I can recognize that since that's a straight angle, they're equal to 180 degrees. So let's just collect like terms and solve this. So we see that 180 equals 20x plus 20, 160 equals 20x, so that makes x equal to 8. All right, there's one last problem on this page that I'd like to go through, and it's going to involve quadratics. All right, here it tells us that the measure of angle TNQ is 36. So let's write out an expression using some algebra to solve for this. Well, we see that TNQ is made up of two angles. The first measures 2x squared minus x degrees, and angle DNQ, which is x squared plus 4x, and they tell us that this is equal to 36. So let's just go about solving it. We'll collect our square terms. We have 3x squared plus 3x equals 36. Now the best way, or I should say the only way to solve any quadratic is to get everything over to one side. So I see that 3x squared plus 3x minus 36 is equal to 0. So once it's equal to 0, we can use factoring, we can use the quadratic formula, and hopefully you recognize that we have a common factor of 3 in all these terms. So if we factor that out, we have 3 times x squared plus x minus 12, and we can divide both sides by 3, giving us x squared plus x minus 12 equals 0. Well, hopefully you recognize that the factors of 12 that have a difference of positive 1 are x plus 4 and x minus 3. So using the zero product property, x equals negative 4 or 3. Now, you have to plug both of these back in because either one of those is a possible answer for x. And when we plug back in, we see that the measure of angle DNQ could be, if x equals negative 4, then angle DNQ is going to equal 16 plus negative 16, or 0. And if x equals 3, then angle DNQ is going to equal 21 degrees. Now, I would also make you be careful here. You should try both of these solutions into this other angle as well, just to make sure that that one of the two solutions doesn't create an impossible angle. And if we do, we see that 2 times negative 4 squared minus negative 4, well, that's going to work out because this is just going to be 2 times 16 plus 4, which is just 36. That works. And if you plug 3 in, you'll get you'll get a positive solution as well. But let's try it. 2 times 3 squared minus 3, and that's going to equal 2 times 9 minus 3, which of course is 15. So both x equals 3 and x equals negative 4 are solutions for this. Okay, Ramblers, just make sure that you can do systems of equations, that you can solve linear equations like number 2, and that you can work with quadratics like number 3. They're going to come up a lot in this class, and you need to have that skill from last year. Okay, Ramblers, thanks for watching.